I would like to say something about incoming inspection to you today. We know that when incoming materials are put into production and a certain proportion of defects are found, the incoming material inspection supervisor will often say, because it is a random inspection, defects may not be detected. Is this really the case? Welcome to the DCLT channel. Let's take a look at the information needed. First of all, if we know the manufacturing process, we will know that incoming material inspection is the beginning of the entire manufacturing activity. These activities are usually planned, that is, there are some reference documents, such as control plans or management plans or QC flow chart. There are also working instructions, such as SOP and SIP. Whether it is before production and assembly or during the manufacturing process, there will be inspection methods, unless it is a special manufacturing. And it is usually a sampling inspection rather than a full inspection, that is, not for all pieces inspections. Therefore, we also need to understand sampling methods. Because today's focus is the probability of defective products being picked up during sampling inspection, we also need to understand the probability distribution function. As mentioned just now, these activities usually have a plan, that is, there will be some pre-made reference documents. Here we take the QC flow chart as an example. This plan describes each station where the product will be put into production, and uses flow diagrams to make the entire plan clearer and easier to read. As shown in the video, as long as the planned man-machine material method is followed station by station, the product can be successfully manufactured. In process, it is sometimes necessary to confirm that the output is a qualified semi-finished product before continuing the unfinished production process. Today we will focus on the first step, which is the incoming material inspection. The incoming material inspection method usually has an acceptance level in the purchase contract with the supplier. From the contract example in the video, you can see related information, such as the sampling plan is based on the MIL STD 105E standard, inspection level and acceptance criteria, etc. In addition, we recommend that the best time to negotiate this content of agreement is during supplier evaluation, that is, when selecting manufacturers to become suppliers. Why do we make this suggestion? We expect that we will have a special chapter to discuss this issue in the future. Let's summarize the incoming material inspection method agreed upon in the purchase contract, which is, the acceptance basis is 1.0, which means that a maximum defective rate of 1% is acceptable. The inspection level is based on single sampling of the second level of general inspection. The steps of sampling inspection are as listed in the video: adopting inspection standards, determining lot size, inspection level, sample number and acceptance level, then sampling and inspection, and finally accepting or rejecting the batch based on the inspection results. For example, the material we want to do incoming material inspection today has an incoming quantity of 1,000 pieces, that is, the lot size is 1,000. Then, based on the second level single sampling of the general inspection in the purchase contract, we can know that the sampling size code letter is J. And then, from the sampling size code letter J and the acceptance quality level 1.0, we know that the sampling quantity is 80 and the acceptance level is 2 for acceptance and 3 for rejection. That is to say, if there are more than 2 defective products sampled, they will be rejected. However, no defective products were found in this incoming material inspection. Therefore, the incoming material inspection result is judged to be acceptable. It also means that warehouse and process personnel can take the material and start production. However, during production, the manufacturing department reported that there were a lot of defective materials. What this means is that when materials are put into production, the number of defective products is found to be higher than the acceptable level. From this case, we can see that the defective rate requirement for the lead lot is 1.0, which means the defective rate is 1%. The defective rate requirements for samples during sampling are 2 for acceptance and 3 for rejection, so the defective rates are 2.5% and 3.75% respectively. The actual defective rate of the lead lot is 1.5%. So why are the requirements different? Before we get started to explain the binomial and Poisson distribution, why is the probabilities different? And, how high is the sampling probability? These two questions seem to be related to 1. Is anything to do with risk? 2. Has the incoming inspection been done? Let's keep. If we further explore the producer risk, alpha, and consumer risk, beta, to understand how the sample level defect rate is obtained from the batch level and determine the acceptance level, AC, and rejection level, RE, and the probability of defective products obtained by sampling inspection is indeed implemented or not, etc. The related video to explain will be made soon. Thank you for watching this video. Again, thanks for your attention.